Our next speaker is Andrew Krug, who is going to talk to us about politics in the cloud, and specifically one form of government, democratization. And he tells me that's not the one that's under attack now, so relax.
I was actually making jokes with the keynote speaker earlier, who literally stood on stage here and just said, be nice to each other, because my thing is mostly a thinly veiled attempt at also tricking you into being nice to each other. And that feels like a lot of the work that we're doing these days is we're just coming up with more and more reasons to work together, and then, you know, slapping an architecture diagram on top of that, and then it becomes a framework or something. I don't know if anybody was here for Adam's presentation just before this, but Adam kind of alluded to the fact that people work in this place that's called the cloud. You know, it's like $100 billion business or something. And Adam's the only person I know that refers to the cloud as a sub-platform. So this is the Democratizing Security talk. Welcome to Democratizing Security in the Cloud. We're, of course, here back in person at Wild West Hackin Fest. If I sound a little funky, I swear I don't have COVID this time, but I have been conferencing for about 3 weeks now, and my voice is a little tired. But I'm not hating the weather. Today, we are going to talk about democratizing security and what I mean by that, especially as it relates to the cloud. We'll look at kind of the attack surface of a few interesting things that have been going on in the cloud, and we'll learn about how attackers are democratizing security faster than defenders. There are a lot of different ways that we can all kind of get to democratize security, right? The paths are many, and today we'll just look at some of the things that you could potentially do in your software development lifecycle to kind of do this thing that we're called democratizing, or some people refer to this as accessible security. In case we haven't met, I'm Andrew Krug. I lead the security evangelism team at Datadog. I'm also hiring if anybody's looking for work. I also teach the cloud security class for anti-siphon training, which we did the last 2 days. I think some of the folks in the room were at that class. We had a great time. Most of my work in the cloud space, though, is on incident response, forensics, and automation. Sort of did a bunch of work a few years back on automating memory forensics and things at scale. And if you go and Google for that, you'll find that. My socials are on the slide. If you want to follow me on Twitter, I'm actually dangerously close to 1,000 followers, and I don't know, if I'm going to get COVID again before I hit 1,000, or if I'll hit 1,000 first. You be the judge. Besides the professional, if you have no interest at all in cloud security, I also like saxophones, old tractors, horses, and Legend of Zelda. Not any specific one, but there's seems to be making a bit of a resurgence. So when you think about democratizing security, you might think that this is kind of like a management level, non-technical presentation, and the topic sounds a lot like buzzwords, right? Well, some of it is, and some of it's actually very tactical, and you can apply to your organization. If you prefer the Clint Gibbler version of this meme, he throws this in a lot of his slide decks. So if anybody wants to boo and say the topic is bad, you wouldn't be wrong. All the links and slides for the talk are available here. If I can trick you into scanning a QR code, you're welcome to visit the GitHub gist and download the slides. So let's take a minute to define what I mean when I say democratizing. My first contact with this idea was actually in 2020, and I was watching this talk from one of the RSA keynotes on the big stage, and I saw Wendy Nather from Cisco, formerly of Duo, talking about the rise of the citizen contributor. And I think this is the first time that this idea really clicked for me, and it didn't seem like anything besides marketing jargon. I'll reference this presentation a few times during the talk, but this was really my inspiration for sitting down and kind of thinking through how we could apply this idea to cloud computing and our use of it as an industry. This wasn't new, though. Like, we had been sort of kicking around this idea of democratized technology since about 2013 or so. So the first Wikipedia page goes all the way back there. It's not a new idea, but it's taken us a while as a security culture to kind of arrive at this as a solution to some of the social problems we're having in our businesses, right? And I think we can all agree that we have a lot of social problems when it comes to security teams working well with software development teams or operations teams. We're getting there. We're learning to be nicer to each other, but we just don't have all the tools that we need. If we want to just define it kind of further, I think that we could define democracy as making technology accessible to folks besides the primary audience, right? So when I think of this, it's security tools and security things that anybody can interact with, even if they don't know anything about security, and somehow they can still end up doing the right thing. And if we break that down into three primary areas to focus on, where we're looking for means of improvement or we're looking for friction, I think that we can define those as control, design, and culture, right? Security gets a bad rap sometimes for being overly controlling, especially when it comes to this design process, and that results in some kind of cultural friction. So what we need to do is we need to move towards a model where we are using collaborative control, simplified design, and an open and transparent culture. And that might sound easy to do, but it's actually really hard in practice to do this 100% of the time. And if you really think about it, I bet each of you can think about a project that you're working on in your security team right now where you're experiencing friction due to a failure in one of these areas. And in the meantime, we've all been going through this massive change in the way that we're showing up to work for the last 3 years or so, right? Like, things are fundamentally different in our professional and personal lives. Our work-life balance is a lot different than it was, and a lot of us that weren't used to working at home have started working at home. And the way that this kind of relates to cloud is that as we have moved things out of the enterprise and out of data centers and into places where it's easier to get at from home, we've actually increased the risk, and we've also increased people's expectation of what that work experience is going to be like at home. Our users have really come to expect a consumer level experience in 100% of the systems that they use to do their job, right? They want that same level of polish on things as their interaction with their like Roku TV or Netflix interface. I remember when I started in security, before security alerting was really accessible to everybody, we used to just throw consolidated syslog up on screen. Maybe we would pipe it to a colorizer if we're feeling fancy, and we would look for things that we should be aware of, right? So that's kind of the original SIM, and if you were feeling fancy, maybe you wrote a Perl script to parse some of this, and you get like an email roll-up at the end of the day. This is a quote right out of that RSA presentation. Nobody wants to go home after work and use their ERP software for fun. I'd go ahead and just kind of paraphrase that and say nobody wants to go home at the end of the day and use their SIM software for fun. And if you do, maybe we should stage an intervention. And I think we could apply this statement to most of the tools we're actually forcing our user base to use as part of their day-to-day, right? If they don't derive joy from it, they're not going to continue to want to use that, especially if they're not security personas. There was one statement from the talk that really kind of made me wonder, though, and that was when she said that we are already democratizing security for the cloud. And I said to myself, I actually really don't think we are democratizing security for the cloud. Maybe we are for SaaS APIs and SaaS services in the sense that we as users control our use of that software. But when it comes to infrastructure as a service or the platforms that we're running code on, we're really not democratizing. And we can do a much better job. Sorry, we're having some audio trouble, it would seem. We can do a much better job making systems accessible and usable by everyone. And when I say everyone, I mean people who aren't security people, or at least people who don't identify primarily as security people. We need to be thinking about designing for those folks first. So remember, when you're asking yourself if a process or technology is democratic, it has to meet these pieces of criteria. It has to be accessible to non-technical users, or at least users outside of the subject matter expertise area, in such a way that they can actually use that technology. So for us, designing for security plus developers seems like a really reasonable place to start, and maybe as a bonus, we'd like to create tools and tactics that scale beyond just security plus developers. Maybe we want to empower somebody in a leadership role to take an action at a certain phase. So based on that test, I don't really think as an industry that we're as good as we could be at democratizing the usage of cloud providers. And I think there's a, we all have different levels of comfort with cloud in the room. I mean, I would say just like raise your hand if you feel really comfortable with your cloud provider. Yet we're all security people and not a single hand went up that said, I'm really comfortable with my cloud provider. Is anybody willing to identify as just not in the cloud at all still? Like you have 0 things? So every person has at least one thing in the cloud and no one is comfortable with the technology stack that they're responsible for securing. So in that sense, we all really, really need to do better to make these things more accessible to everybody. And one thing I do know, though, is that attackers are democratizing their tools, tactics, and techniques way faster than defenders. And usually what this looks a lot like is automation. But also, due to the distributed nature, anonymity, and dogged pursuit of a single goal, attackers are sharing knowledge a lot more freely than defenders. They automate repetitive tasks, they develop technology to make the application of their methods more accessible, and they spend a fair bit of time actually thinking about user experience. Just think about the amount of hours that goes into running a decent phishing campaign and taking a user happy path to clicking on that piece of ransomware. And we see this all the time, right? The biggest difference is that, and we've all heard this before, attackers only have to be successful one time, and defenders have to be successful 100% of the time. So I borrowed a couple of bits from this presentation from a blog post that somebody who works on my team at Datadog wrote and gave a readout on at Sans New to Cyber. It was called Fantastic Hacks and Where to Find Them. It's kind of a look back year in review at cloud breaches. For this talk, I thought it would be fun to do a little bit of analysis and categorization on the types of attacks that we're seeing. If you want to go check out Fantastic Hacks and Where to Find Them, I threw the link in the slide deck here, and it's also on that GitHub gist that the QR code was attached to. Seriously, the QR code really is only attached to a GitHub gist. It's safe to scan. You can trust me, I swear. So how are we doing? The question I always ask is, are we getting better at preventing the top 3 types of attacks? And the answer really seems to be that we aren't. The majority of these are the same root cause that I started talking about when I began speaking on cloud security back in 2015. So these are, the top problems are the result of credential leaks, right? That's a bit unsurprising. But this still isn't really a problem that we've adopted solutions for as an industry. We're leaking credentials all the time. They're very impactful. They result in data breaches. They result in crypto mining. But we're really kind of treating the symptom and not the problem. There's plenty of solutions out there, but we're just not seeing the adoption curve really move at all. I might say it's not moving fast enough, but it's really not moving at all. In fact, if we look at the metrics, we're just as bad as we were in 2015. Insider threats here actually really surprised me, how prevalent they were in the last year's worth of cloud breaches. They made up over 8%. This is also kind of a credential management problem as well, in the sense that these were the result of a termination of access issue in many cases, where you had an employee depart or sever their employment relationship, and they came back months and months later and actually exfiltrated data or defaced an environment or committed some other act of corporate espionage. So long after somebody had left, they maintained privileged access. And then there's misconfiguration. Misconfiguration tends to be these S3 buckets, open to the world types of breaches. These are highly impactful due to the amount of public data that's exposed in every single one of these, and I don't think that we go a quarter without seeing a headline that says Amazon server exposes data or something like that. Usually they're talking about S3. They're not actually talking about a server running in AWS. And if we loop in server-side request forgeries, which I also put in that credential category, makes up about 62% of cloud incidents. So that's really, really significant, right? And I do that because generally the goal of an attacker using an SSRF to gain access is to exfiltrate some kind of machine level credential to another place and then leverage that to gain access to more data or exfiltrate data. So if we look at the top three there, that means that roughly 82% of incidents are not related to vulnerabilities in the environment at all. They're actually mistakes that are made by the folks who work for your companies. So your biggest threat is actually the people who have access and are using your cloud services. Gartner also predicts that misconfigurations are going to increase over the next 2 years. This quote is straight out of a Gartner report. It says that they believe it will increase to 99% of the cause of breaches due to the increasing complexity of environments. Which isn't actually that hard to believe because things are getting more and more complex. But at the same time, it's like, thanks for the vote of confidence. You know, I really think that we actually can do better at detecting these things early and preventing misconfiguration. So what we really need is we need security process and technology that's for the people and by the people. And what that really means is it's something that development teams and security teams enjoy using, and they're going to adopt consistently, especially in the cloud. Security for the people and by the people can solve many of our problems, because beyond those top three attacks, if you examine the rest of the actual path of the attacker beyond initial access, the rest is pretty unsensational, and we're pretty detecting and remediating it. Sure, maybe the root cause in a small percentage of cases is something as awesome as Log4j or Spring for Shell, but the really cool new zero day isn't the thing we need to pay attention to. We need to pay attention to the techniques, tactics, and procedures that are highly predictable. We're seeing tons and tons of the same attacker run books, right? This is great for democratizing security because we can make prevention, detection, and response more accessible to everyone by using things like plain English to describe these attacks and also automation. The headlines don't help us with this, though, when it comes to making the business believe sometimes that we can solve their problems. If you're really starting to dig into these things, they've got great headlines. But instead of focusing on the indicators of compromise, journalists are focused on words like devious and highly sophisticated to fool you. I recently was asked to take a look at this ransomware write-up from the DFIR report. I don't know if anybody ran across it as well. It was called the quantum ransomware. Did anybody see that? It was really just a really speedy ransomware. And it started with a shortcut inside of an ISO, but then if you look at the rest of the path, it's pretty unsensational. It loads a DLL, it dumps credentials from LSAS, it's even got plain old Cobalt Strike in there. What's incredibly sophisticated about that? The only thing that's really impressive is that the democratization of this attack has made it so the automation has moved faster and faster than ever before inside of an environment. I think we're all really tired of hearing that automation and these predictable types of attacks is sophisticated. And in many ways, these are just taking advantage of the fact that when we put traditional on-prem enterprise technology in the cloud, it still requires the same security that we required on-prem in addition to the cloud concerns. So really, if you take an enterprise and put it in the cloud, lift and shift, it's just your enterprise on cloud. In some ways, running enterprise services on cloud becomes more challenging because the perimeter changes. Formerly, things that used network identity as a form of total identity are no longer really okay. That's because the cloud has these always-on, always-accessible endpoints. And if an attacker gains access to your cloud provider's control plane via a leaked credential, it's pretty much game over. So related to those problems, but slightly different than those problems of just kind of like taking your enterprise and lifting and shifting it into the cloud, we have things that we call cloud-native technology now. And arguably, these need even more democratizing than our traditional enterprise infrastructure. These are things like Kubernetes, serverless technology like AWS Lambda, and platform as a service like AWS Fargate and Google Cloud Run. These environments support building things at a really different scale in a fundamentally different way. So they inherently have more complexity, and like everything else, there are trade-offs in choosing to build on top of those platforms. When we think about what technology to build on, and when it comes to cloud providers, we always need to consider the trade-offs from a threat model perspective. And also, when it comes to the accessibility of that technology to our engineering teams, especially non-security teams. As you go up and down this pyramid I've sort of built here, you have more control over the things that you have to work on more. So at the top of the pyramid, you might notice things like fat VMs, like regular AWS EC2 instances. And when we go down the pyramid of more control to less control, you'll see that with ease of use, we often have increased visibility concerns because those are the trade-offs. We're not operating the underlying infrastructure, so we actually need more instrumentation, not less. I always like to ask folks in the cloud security class, what do you think is the most expensive thing in your cloud environment? Most people will guess compute. And that's generally wrong in a mature environment. The thing that costs the most tends to be observability, like actually monitoring, logging, and alerting on the things that you're running. So this diagram isn't to say that you shouldn't build your application on top of something like AWS Lambda or ECS. It's just an acknowledgement that if you do, you need to consider adding visibility into the way you build that service or application. Having a plan at the outset, socializing that plan, and having clear indicators of compromise that you can make visible for security teams and not for that application is really key to democratizing the security. And if technology wasn't making things challenging enough, we have this shift in the industry in the way that we're building things. Our industry doesn't build monolithic applications anymore on top of model view controller frameworks. We're shifting to microservices. And on the slide here is actually a network flow diagram from a demo application we build at Datadog to kind of demonstrate the way the tooling works. And it's modeled after an e-commerce store, like a regular e-commerce store. I know it's a little small, but you might note all the little services that we're all responsible for securing and running these days. Things that you normally wouldn't think of as part of a shopping cart experience, like fraud detection, product recommendations, ad services. These are all places to hide. This idea of microservices and 12-factor applications has made our lives as defenders a lot more challenging. And that's why simplification and democracy are becoming increasingly important, right? We actually have to empower the software development teams to take care of these things and think about the threat model on their own. So how do we do that in the cloud? You might be saying, okay, Andrew, I believe you. Building for the cloud is hard. It's easy to get breached in the cloud. These applications are really, really complicated. What do we do about it? This is where a lot of folks will throw up this diagram and say that devsecops is the ultimate answer to this problem. Sounds easy, right? Just bake a little security into every step, and we've totally democratized security. Well, I'm actually not going to tell you that today because I don't think that devsecops alone is the answer. The problem with these continuous flow diagrams is that they become different things to different people based on your persona. And just because we say that we're putting security in at every stage doesn't mean that we've truly made security accessible to everyone. The tools are still hard to understand for a lot of engineering teams, and DevSecOps workflows become full of manual approvals. If you show this diagram to a boots-on-the-ground security person, they usually see a gate at every step, when really we should be applying guidance for these engineering teams and continuously measuring. So, in order to really build a culture around DevSecOps that's collaborative and provides more guidance and not gates, we have to build this democratic foundation in the way that we're designing these processes. And that foundation is going to create a common language that we can use that's really owned by engineering, and security sits then in more of a guidance and tooling role. If we're doing that, we can really scale the impact of our security team or security engineers because we've then put the capabilities in everybody's hands, and the security team is just sitting back and measuring. Let's look at an example here. I can't think of a better example of something that's harder to make accessible and democratized than identity and access in most clouds. Does anybody use the IAM system in their cloud provider? Would anybody say that it was straightforward? These systems are challenging to understand, right? I worked as a kind of an identity specialist for 3 years or so, and I have a really hard time using these things. The difference between you and an identity engineer is that the identity engineer has accepted that it's going to take them a long time to carry out their task. Engineering teams, when they use this, they make mistakes or they give up completely when they're using them. And when an engineer gives up, they usually blow permissions wide open. Certainly not ideal. And if credentials are the root cause of all of these security incidents on our pie chart, the answer is really to democratize more identity and access management. Because the blast radius of any security incident that involves credentials is dictated by how permissive a specific set of permissions is. We can also protect resources given things like condition keys, which are new to the AWS cloud in the last several years or so. And they are ways to describe when a credential is allowed to be used, under what conditions is that IAM policy statement always true. So there's at least 2 areas here that we can primarily work on if we're just thinking about identity and access. We can work on the developer credentials themselves, or we can work on minimizing the blast radius of an incident by making IAM more accessible. The first part of that problem we've kind of solved from a technical perspective. The technology for this is really better than ever, and that's the long-lived credentials that live on developer systems that we're constantly putting in places that we shouldn't. There's a bit more socialization that we need to do there, and we kind of have an adoption problem with this because when cloud providers first launched support for single sign-on, it was a really, really complicated setup and the user experience was terrible. The user experience on the command line was even worse than the user experience in browser. So this, of course, isn't true in 2022, but the technology was so bad prior to now that it left this lingering perception that it's impossible to provide good UX and single sign-on for the cloud. Back to our leaked access key problem, though. That was the single sign-on might help you solve your problem slide. If you're not familiar with cloud provider authentication, there's 2 primary types, right? There's developer authentication or human authentication, and there's machine authentication. And human usable credentials are these things like access key pairs, and machine credentials are these short-lived tokens that are vended by the machine's metadata service that are good for about 15 minutes. If our goal is to prevent leaked developer keys first, we should start off by identifying the problem. And I would assert that the problem is part education and part insecure examples. I run across tons of examples still on the web in code, and if you want great first-time open source contributions, just go to docs repositories and start getting rid of insecure examples of how to play with cloud credentials. This snapshot up on screen here is actually from the Boto 3 reference, which is the AWS Python library for interacting. And it actually stubs out the AWS access key and the AWS secret access key in the object there, and those are actually optional. But a lot of people don't read this and think that those arguments are optional. So they immediately copy-paste and they start hard-coding credentials in something, and the next thing you know, they've leaked their credentials. I actually made this mistake when I first started writing code for AWS because I didn't know how the default credential provider chain even worked and what the other ways were to get credentials to the AWS SDK. Then we need to figure out, after we've kind of addressed that education problem, how do we measure and visualize the scale of the problem? In this case, the easiest way to do that is with something like Trufflehog. I don't know if anybody here is a fan of Trufflehog. We don't even really need something as fancy as Trufflehog to detect these things. It's been around for a bit. They just released version 3. It handles all the big cloud providers' credentials with regard to scanning commits. But AWS credentials are regexable. They're totally easy to detect in code. So you can get these with all kinds of different static analysis, and you can create dashboards and things of how often folks are leaking credentials, and you can drive towards a different kind of solution if just doing single sign-on isn't really working for your business. The machine credentials are a bit more complicated. Since sessions are short-lived on the machines, the best thing that we can do here is really try to prevent theft of credentials in the first place. The best way to do this is actually to change an insecure default and move to a version of the credential vending service on the instances called IMDS v2. AWS introduced this in response to the Capital One data breach, and I bet If I ask for show of hands, there are people in this room who are probably impacted by the Capital One data breach. IMDS v2 is the best mitigation that we have for actually shutting down SSRFs. It's really just a socialization issue that we need teams to think about turning this on anytime we're talking about a machine in the cloud having some kind of privileged access. IMDS v2 introduces this token granting token, not dissimilar to a ticket granting ticket, by the way. There are no new ideas. They're just ideas that we continue to recycle. It gates those credentials behind a service that requires that token granting token, and the token granting token has to have a TTL of 1 or less in order to call that service. So effectively, it shuts down SSRFs. This still doesn't really help with remote code execution or things like Log4Shell and Spring4Shell where you have privileged access on the box, but this is a great step in the right direction for shutting these types of attacks down. The socialized portion of IAM is a bit harder, but it's still possible to do. Like, we can still teach people to reason about how these things work by simplifying some of the concepts. On this slide is an example diagram I use frequently to introduce folks to the identity and access decision-making model in the AWS cloud. Is this complicated? Kind of, but it's not as complicated as the giant diagram that actually represents the access decision facility in AWS. So just taking somebody and walking them through the idea that there is a thing that has to make a decision about any access decision for any API call you make in the cloud is a great step in the right direction. One of the ways that we can also socialize this and get more people involved in identity is to make the interaction itself easier. On screen is an example from an open source tool called PMapper, and I think PMapper is a great reference for democratizing IAM. Has anybody heard of PMapper before? One hand. PMapper is an open source project that allows anyone to ask it who can do what using plain English and see if that person can carry out that specific task. And this is the way we should be thinking about these systems. Sometimes we call this low code or no code, but really this is just English, human language. Acronym-free human language, easy to understand, usable by many folks, not just security people. And we can, of course, detect and visualize after we do all that stuff by creating dashboards and doing things like continuous auditing of the environment for undesired settings like IMDS v2. It's not about measuring is it done or is it not done. It doesn't become binary, right? It's about measuring the adoption curve for something that you're trying to get development teams to onboard. The most successful teams tend to set goals and drive towards them, not just say, here's a hard line in the sand, we're not going to use IMDS v1 after this state. Again, education, socialization are going to be your friend for ensuring that things that you don't want in your environment don't end up in your environment. So if you think these sound a lot like user stories too, you'd be right. And there's a great talk that was inspirational to me while I was building this talk by Alyssa Miller on writing great security user stories and how that relates to threat models. I'd encourage you all to go and watch this presentation and then sit down with an engineering team and have them participate in creating some security user stories with you. Not particularly cloud-focused, but just generally good advice. There's also community involvement in socializing sometimes as well. We can all be advocates for changes in some of these products. AWS is a very, very large business, and the ecosystems of companies around AWS sometimes don't move as fast with the security controls as we would like them to. So this is a great example. The IMDS v2 Wall of Shame is a Git repository that's just a list of vendors that don't support the secure version of that service. It's a great way to get them motivated to go and support the more secure version of the metadata service. Ideally, things like this wouldn't have to happen. IMDS v2 has been out for 3 years, which is why in this case I'm only a little okay with the fact that we're shaming them, but it does seem necessary because companies are popping off this list since Scott Piper started this Git repository. So let's look at a final example here of democratizing. Sometimes our detections break. We're all good at detection, but we're not necessarily always good at testing detections. And we don't know that they're broken until we actually miss a really important event. So why do detections break in the cloud? If you've ever parsed CloudTrail data, many of the same reasons that they break on-prem, except that we also have components outside of our control to deal with. I'm sure if you worked on a SIM in-house, you know the pain of something like a dictionary becoming a list, or a dictionary becoming a list of dictionaries, and all of a sudden that breaks your detection or it breaks your indexing, and then all of a sudden you can't build alerts that actually work against that log source. So the way that we're measuring and visualizing in this case is by using a tool that we recently open sourced at Datadog during Q1. It's called Stratus Red Team. Stratus Red Team is a cloud-native adversary emulation tool for AWS and Kubernetes. And by the way, we're democratizing this by making attacks understandable to everyone by using the MITRE ATT&CK framework to describe the techniques, tactics, and procedures, or TTPs, and also giving the developers the one-shot ability to detonate these things inside of a cloud environment and see if they're detected. So here's a quick demo of how that works end-to-end in a detection testing scenario. Ooh, and the video is actually working. I don't see it in the speaker notes, so I'm just going to have to watch on screen. So this is Stratus spinning up and describing all of its capabilities. It has a lot of them. We're also spinning up a Kubernetes cluster. And then we got some detections there on screen, the things that we want to see if we can continuously detect. That's step one, make some detections. In this case, we're using the standard Datadog query syntax in our example. Looking at Kubernetes audit logs, we're also looking at persistence via creating additional IAM users in the cloud. Then we're going to install Stratus Red Team as an API, because fun fact, when we built Stratus Red Team, we built it so you can bind to it in Golang to create other tools. So that's what we've done here to create kind of an end-to-end test pipeline example. So we got a little script that's going to show on screen that just describes which alerts and which TTPs we're going to test. Someday we'll open source this too. Then we're going to detonate the TTPs, and we're going to monitor how much time it took the SIM to detect those attacks. So you can see it detonating, and you can actually see that the attacks are detected quite quickly. I think one of those is like 6 seconds to detection, 9 seconds to detection. And at the end of that, the little wrapper that we wrote around Stratus is actually going to emit a metric back to the monitoring platform to say how long it took end-to-end for each platform for that specific TTP to be detected. Then we're going to go back to the platform. We're going to confirm the detections. So it should generate alerts. It looks like it did. Of course, those alerts have all of the information that we would need to go and remediate that. And then we also have a sample dashboard that we've created that shows the number of TTPs that we've detected and also the change in time to detect over multiple deployments of the same piece of software. So not only can we empower developers to use this tool to just run these TTPs inside of the environment, we could create a service level objective around how quickly certain types of behaviors need to be detected. In the cloud security class, we talk a lot about how fast do you need to detect something in order to be effective at preventing a breach completely, and when does an SLA prevent you from doing that fast enough that the attacker is going to get away with some data and you're going to shut it down, let's say 15 minutes after they've actually come and gone. So if you're more of an architecture diagram individual, this is what the workflow for that looks like. You have a git commit of some kind inside of your CI/CD thing, which in this demo was AWS code build. We're running Stratus Red Team. Stratus Red Team is executing inside of a clean room environment. It's very, very hard to run tools like this in a production environment because the attribution of events back to the original actor is really, really challenging. And you can ask me about that stuff. You can also ask Adam Mashinji about that stuff. We both have spent a ton of time thinking about problems like this. When that runs, of course, we're going to get logs back from the cloud provider's control plane via CloudTrail. We're going to run that through our SIM. In this case, we're using Datadog for the example. Then we're going to use our little script to pull the SIM and see when the event was detected. And then if we fall below our service level objective for detection, we're going to emit a message to a messaging platform of our choice. In this case, on the diagram, it says Amazon Chime, but it could be anything, text message, PagerDuty, Slack message, whatever. So we all know in this room that TTPs are great, right? And this is just kind of building on that idea that describing attacks as techniques, tactics, and procedures is way better than describing things as CVEs. And the move to MITRE ATT&CK has really, really helped us there because we're throwing around less acronyms. We're making things really, really understandable and communicable for the rest of our organization. So if you like that tool that you saw on screen and you want to pull it down, it does ship with 23 TTPs for the AWS cloud and 6 for Kubernetes. All of those attacks can be simulated by anyone with access to an account or an expert red teamer, and I'd consider that a win. I'd even call it democratizing. So if you think that demo I just showed you is actually cool, we have not built out the complete feature for Stratus Red Team that does the end-to-end part, and I have a GitHub issue here. If you think it's neat, if you could just go and give it a thumbs up, a +1. If I didn't show a feature that you think the tool should have, go ahead and throw a comment on there. And I'd like to do a little bit of product management before we actually decide to mature that prototype. The Stratus tool is available, just not the end-to-end detection that emits those metrics. So with that, I'll ask you the question, maybe we can chat after this. What pieces of security are you democratizing now that you can identify what that means inside of your business? Would love to talk to you at lunch. Again, all of the links from this talk are available in this GitHub gist. You can scan the barcode if you're not a barcode scanner. The bit.ly URL is down there at the lower left. Once again, I'm Andrew Krug. I'm a lead security evangelist at Datadog. That's how you can get a hold of me. Please do get a hold of me if you have any questions. Thanks.
Andrew, thanks for coming and telling us about how to apply democracy in the cloud. Anybody got any questions? I don't think I had any from the Discord. And if somebody posts one, it'll pop up and I'll see it. So we'll take the one in the house here.
Oh yeah, what the data you have for your pie chart, what was that?
Oh yeah, sorry. The question was, where is the data from the pie chart that I showed? It's actually from the security researcher Ramanak, I think is the way that you would pronounce the name, and it is linked in the slides, and it's linked in the GitHub gist. It's basically just it's a public repository that he does where he tracks all of the breaches that are in the news through the year. It's not based on some report like VDBIR. It's right here in the slide, so up there. And he doesn't categorize those. I actually think that would be a significant improvement to this repository if somebody wanted to make a community contribution, is to categorize them at a broad level based on what initial access was, what blast radius was, what the techniques were that were used inside the environment, because then we could generate much better metrics. Any other questions?
Over here.
The question was for the TTP from the automated tooling, what's the format for those? If you go there, so one, shameless plug, on my Twitter page, there's a deep dive talk on Stratus Red Team from last week that I did at AWS Summit North America. But for the actual tool itself, if you wanted to contribute a TTP, the format is just Terraform. So Stratus Red Team is a cloud-native wrapper around Terraform executing those TTPs. And if it's not something that we can do natively in the cloud control plane, we actually spin up an EC2 instance or a container, and then we use the systems manager agent to execute commands inside of that EC2 agent or container. So you could even do something fancy like chain Atomic Red Team to Stratus Red Team. That'd be really cool. If you do that, please let me know so we can recognize you in the project. We don't send t-shirts yet, but I have stickers.
Use the smart one.
All right. Any other
Target
questions?
acquired. All right. Thanks, everybody. And I could tell you all the other things that you've been doing, but it's lunchtime, and I know you won't listen. So go eat lunch. We'll see you back here in an hour. And then I'll tell you the other stuff you could be doing.
Thanks, everybody. Great to see you.